Statistical analysis plays a fundamental role in management accounting by transforming raw data into meaningful information that supports planning, budgeting, forecasting, and strategic decision-making. Measures of central tendency and dispersion enable managers to summarize operational performance, evaluate variability, assess business risk, and identify underlying trends in financial and non-financial data. In addition, probability theory and normal distribution analysis provide quantitative tools for evaluating uncertainty and making informed business decisions under conditions of risk. Consequently, statistical techniques constitute an essential component of modern management information systems. Measures of central tendency describe the typical or representative value within a dataset. The three principal measures are the mean, median, and mode, each providing different insights depending upon the characteristics of the data. The arithmetic mean is the most widely used measure and represents the average value of a dataset. For ungrouped data, it is calculated by dividing the sum of all observations by the number of observations, where x represents each observation and n denotes the number of observations. The mean incorporates every value in the dataset and is therefore highly suitable for financial analysis, budgeting, and forecasting. However, it is sensitive to extreme values outliers, which may distort its representativeness. The median is the middle observation when data are arranged in ascending order. It divides the dataset into two equal halves and is particularly useful where extreme values exist because it is unaffected by unusually large or small observations. Income distributions and property prices are common examples where the median provides a more representative measure than the arithmetic mean. The mode represents the observation occurring most frequently within a dataset. It is especially valuable for categorical or nominal data and helps identify the most common product sold, customer preference, or operational outcome. Unlike the mean and median, datasets may possess more than one mode or no unique mode at all. For grouped frequency distributions, the mean is calculated using class midpoints and frequencies, where F denotes frequency and X represents the midpoint of each class interval. Grouped means provide efficient summaries of large datasets where individual observations are unavailable. While measures of central tendency indicate typical values, management accountants also require measures of dispersion, which assess the spread or variability of observations around the average. Variability provides important information regarding operational consistency and business risk. The variance measures the average squared deviation from the mean for a population or divided by N1 for sample estimation. A larger variance indicates greater variability and less predictable performance, while a smaller variance suggests greater operational stability. The standard deviation is the square root of the variance and measures the average dispersion of observations in the same units as the original data. Standard deviation is widely used in budgeting, investment analysis, quality control, and risk assessment because it provides an intuitive measure of uncertainty. Both grouped and ungrouped data can be analyzed using these statistical measures through appropriate weighted calculations. Another useful measure is the coefficient of variation CV, defined as the coefficient of variation expresses dispersion relative to the mean and enables comparison between datasets measured in different units or possessing different average values. Lower coefficients indicate greater consistency and lower relative risk, making the measure particularly valuable when comparing investment opportunities or alternative production processes. Management accounting also employs expected value analysis when decisions involve uncertain future outcomes. Expected value represents the probability-weighted average outcome of alternative scenarios and is calculated as, where P_I denotes the probability of each outcome and X_I represents its associated monetary value. Expected value analysis supports investment appraisal, inventory decisions, pricing strategies, and project selection under uncertainty by identifying alternatives that maximize expected financial benefit. Although expected values provide rational decision criteria, they represent average long-run outcomes and do not eliminate individual decision risk. Many management accounting applications assume that data follow a normal distribution, a symmetrical bell-shaped probability distribution characterized by predictable statistical properties. In a normal distribution, the mean, median, and mode are equal and located at the center of the distribution. The curve is perfectly symmetrical around the mean, with frequencies decreasing gradually as observations move further from the center. An important characteristic of the normal distribution is the 68-95-99.7 rule. Approximately 68% of observations lie within one standard deviation of the mean, 95% lie within 2 standard deviations, and 99.7% lie within 3 standard deviations. These predictable proportions enable managers to estimate probabilities associated with production quality, customer demand, inventory usage, and financial performance. Normal distribution tables and graphs provide cumulative probabilities associated with different standardized values, z-scores. A z-score measures how many standard deviations an observation lies above or below the mean, where x represents the observation, /mu, the population mean, and /sigma, the standard deviation. By interpreting z-values and probability tables, management accountants can estimate the likelihood of achieving specified production targets, exceeding budgeted costs, meeting service standards, or identifying exceptional observations requiring managerial attention. Collectively, measures of central tendency, dispersion, expected values, and normal distribution analysis provide powerful quantitative techniques for summarizing business data, evaluating uncertainty, forecasting future performance, and supporting evidence-based managerial decision-making in modern organizations.